Okay, so this is going to be geometric. For arithmetic, we did already, right? The difference of consecutive terms is constant. That's arithmetic. For geometric, it's the ratio of consecutive terms is constant. Right? So again, consecutive means one following another, right? So to check this, you go 2 divided by 1, compared with 4 divided by 2, compared with 8 divided by 4, right? It's always the term that follows by the term before. And if that is constant, then that's called the common ratio. And then we use the lowercase letter r. If you had to describe the pattern, you wouldn't say, oh, it looks like it has a common ratio. You'd probably say it looks like I keep multiplying by the same number. Okay, that number is the common ratio. Right? If the numbers are getting bigger, then the common ratio is bigger than 1. Right? That's why when you multiply, you get a number bigger than you had before. If the numbers are getting smaller, it must be that the common ratio is less than 1, a fraction less than 1. Right? So you have all that written. So tell whether these sequences are geometric. So again, you have to do the common ratio. Let's see, in this first one, 10 over 4 is about 2.5. Not about, it's 2.5. 18 over 10 is 1.8. So that's not constant, so that's a no. That's not geometric. Okay, how about this one? 625 divided by 125. Oh, that's reversed. Make that bigger. 125 divided by 625 is 1/5. Right. And so is 25 divided by 125. And so is 5 divided by 25. And obviously so is 1 over 5. So that's a yes. Every time that ratio was 1/5, so we have a common ratio, r equals 1/5. So tell whether the sequence is geometric, and if it is, state the common ratio. What'd you say? It's a yes, right? It looks like again, you don't have to necessarily do the divide. If you could just see, it looks like I keep multiplying by the same number, then that is the ratio. And what is that number you keep multiplying by? -2. So this is definitely going to be 8 over -4 equals -2. That's the R. So that is yes. Okay, so just like we had with the arithmetic, we have a formula, an explicit formula for the nth term of a geometric sequence. And I'm not going to get out the formula sheets again, but I mean they would be in the next column there. So again, that's the a sub n means this is a formula for a term in the sequence. You plug in the n, you get back out the value of that term in the sequence. The A1 represents the first term, the R represents the common ratio. So those are the two things you got to plug in, A1 and R. And just to point out, so if I was using this formula, if I said find A1, then I would have A1 times R to the 1 minus 1, which is A1 times R to the 0, but anything to the 0 is 1. So then that's why you just get A1 back again. That's why it has to be n minus 1, right? It wouldn't work if you made it n. It has to be n minus 1. Okay, so find the formula for the nth terms of these two sequences. So for the first one, I'm going to write down my formula first. an equals a1 r to the n minus 1. Okay, so the a1 is pretty clear. Okay, what is the r in this first one? R equals 20 divided by 4, which is 5. So here's the formula. an equals 4 times 5 to the n minus 1. And that's it. There's no simplifying to do. Okay? Does not equal, just to be clear, right, this does not equal 20 to the n minus 1. Okay, so don't do that. That is a fairly common mistake. But you can't multiply the 4 times 5 because the 4 is not being raised to the same power. So don't try to simplify it if that's done. Okay, how about the next one? We see the first term. What is the r? Negative 76 over 152 is negative 1/2, right? So here's our formula. an equals 152 times negative 1/2 to the n minus 1. So try to do the same thing for that. So what is the r in this case? 15 over 3, which is 5. And so the formula is an equals 3 times 5 to the n minus 1. So far, so good? Okay, now this is like the one homework that we did, right? They've given us 2 terms in the sequence, but neither one of them is the first term, and we don't know what the r is. So how are we supposed to find the formula for the nth term? How can we use these two to find out something that we need? Say again. A2 times r equals A3, and then what? How many times are you going to multiply times r to get to A4? Twice. Okay, so what are you multiplying times A2? R squared, right? If you multiply times r and times r again, it's actually r squared that you've got to multiply by. So I think this is intended to be a you try, but I'm just going to go ahead and do it anyways because I didn't do one like it before, and I'm not sure why I didn't have that in there. But again, this one I should have gone A2 equals, A2 times r squared equals A4. Okay, well we know the A2, that's negative 12. And we know the A4, that's negative 3. So we can solve for r squared. Right? R squared equals negative 3 over negative 12 is 1/4. Okay, now take the square root, what do you get? The square root of 1/4. Okay, It's 1/2. All right, so let's say if we know the R, now we need to find the first term. So how can I find the first term if what I know so far is the R and A2? I mean, if you multiply each term by 1/2 to get the next term, then how would you find the term before it? Multiply by 2, right? It's multiplied by 2. So I mean, I could write it out like this. A1 times 1/2 equals A2. But A1 times 1/2 equals -12. When I solve that for A1, I'm going to get A1 equals -24. Right? So now I can say AN equals -24 times 1/2 to the n minus 1. Again, how would I check that? Yeah, try it with 2 and 4. Those are the only two terms that we've got. So let's see, if I plug in a 2, I would get 1/2 to the 2 minus 1, which is 1/2. So that's -24 times 1/2, which is -12. For 4, I would get 1/2 to the 3rd, which is 1/8. So -24 times 1/8 is -3. Okay, there's actually another possibility here. Remember, when you take the square root, you get either positive 1/2 or negative 1/2. I mean, is that possible? Sure, that could work. If R is negative 1/2, then what is A1? It's going to be positive 24, right? If you keep multiplying by negative 1/2 to get to the next term, then we would have to multiply by -2 to get to A1. So in that case, the A1 is going to have to be positive 24. And the formula then is AN equals positive 24 times -1/2 to the n minus 1. Now let's just make sure that it works. Right? If I plug in 2, then I got -1/2 to the first, which is -1/2, times 24, -12. That works. If I plug in 4 for n, then I get -1/2 to the third, which is -1/8. 24 times -1/8, -3. So either one is actually would fit this. You know, they're not the same. You know, because one of them, because the -1/2 there is alternating signs. Right, and the other one is not. It's just straight negative. But it works. Okay, so the recursive, we have a recursive formula for this, just like we did for arithmetic. And it says, you know, just the basics. If you want to know the nth term of a geometric sequence, then you multiply the term before it times the common ratio. It's kind of the way you actually think of it. Just whether or not you see it when you look at that, right? So multiply the term before by R, and you get the next term. So write the first 6 terms of the sequence, right? So of course they have to give you the one term to start with, and then when you look at this formula there, what does the 3 represent? It's the R, right? Remember, it's the term before times the common ratio. So by writing that 3 there, we know R is 3. So the A2 will be A1 times R, which is 1 times 3, which is 3. What will A3 be? Right, it'll be 3 times 3. Right. So that A4, 3 times 9. Right. A5, 3 times 27. right? And every one of these, right, the 3 goes there, the 9 goes there, 27 goes there. And what's the last term? $243, right. So that's, I think that's all we say about that. Now we'll write the recursive formula for that. Okay, so the formula goes an equals r times an minus 1. So I need to plug in the r. What is r? Right, again, it's 2.5. 40 divided by 16 is 2.5. You know, you could leave it as a fraction, 5/2. But let's say I'll leave it like that. An equals 2.5 an minus 1. Okay, does that completely describe our sequence? You got to put the first term, right? The first term is 16. And now, together, those two completely describe that sequence. Okay, I think that'll lead us to how do you find the sum of a geometric series? And there's going to be two formulas here, right? The first one is for a finite, meaning it's just so many terms that you're adding up. And that's why it's got a subscript of n. And you can see the things that we need to plug into this formula. In order to find the sum, we need the first term, we need the r, and we need the number of terms. Okay, if you've got those three things, then you can use the formula. And unlike the arithmetic, we don't need the last term. There's no part of the formula that would ever ask for that. We just need those three things. So what is the sum of the first 16 terms of this series? So again, let me write down our formula. Fn equals a1 times 1 minus r to the n divided by 1 minus r. Okay, so let's see, a1 for r. What is r in this case? It looks like it's 12 over 4, which is 3. Okay, and then how many terms? 16. So let's plug all that in. This is going to be S16 equals 4 times 1 minus 3 to the 16th divided by 1 minus 3. So especially when you deal with geometric sequence series, I mean, the numbers can get quite big, quite fast. I mean, if you've got something like 3 to the 16th, that's going to be a huge number. So you're going to use a calculator. One way or the other, you're going to end up using a calculator here. And I can show you, I'm going to show you a couple different things here. Let me delete this. Maybe I can put it over there. That'll work. So, I mean, the first thing I can do is 3 to the 16th, right? 3 hat 16. Enter. Okay, now I need to make it 1 minus 3 to the 16th. So I'm going to go 1 minus second negative sign, that's answer. It brings up the last thing that I got when I hit enter. So that'll be 1 minus 3 to the 16th. Okay, now I've got to divide by 1 minus 3, which I'll just say that's negative 2. Divided by negative 2. Okay, and then I've got to multiply times 4 times, can I see that? Yeah, times 4. And it looks like it's 86,093,440. 93,440. Okay, but I was going to show you, I like to do, when I do this stuff here, this is something that we haven't really done a lot yet, but we will, especially as we get ready for the SOLs. But when you start working with this formula especially, and you got these minuses going on, and you got something raised to a power here, there's a lot of places to make mistakes, especially if, for example, the R is negative. Like in this case here, if we had a sequence of everything else is the same, but the R was -3, then you got to take into account, well, what if it says 1 minus -3 to the 16th, then what about the minus and negative? No, it wouldn't be, because first you got to take the negative and raise it to the 16th power, and now it's positive, right? But that is a common mistake. So you can have a lot of issues when you're trying to do this, and there's the minuses that are already there, and then that could be a negative, and then that could be a positive or even or an odd exponent. Like if that was to the 15th power, then it wouldn't matter, right? Then if I take -3 to the 15th, that's negative anyway. So yeah, they will cancel, but there's a lot of places to make mistakes on that. So what I like to do is this. I'm going to use the calculator to do the whole calculation. But first what I'm going to do is I'm going to store in the calculator the values for A1 and R and N. And then I'm just going to type the formula itself into the calculator. And it'll take care of the rest of it, and there won't be any room for errors at all. Okay. Now, I'm going to store because I can't put a sub 1 in there. I'm just going to call A1 is going to be A. So in your calculator, you've got all the alpha keys above. So to access them, you hit alpha, so alpha A, right? R is on the multiplication key right there, and N is on the logarithm key, which is right there. So if I want to store, like if you haven't done this, you want to play along with this, because eventually this can be very useful. If I want to store A equals 4, then first you type 4, right? Then this button right here that says STO, that's store. So you go 4 store alpha A, enter. Right, like this. 4 store alpha A, enter. Okay, now we got to store R. R is 3. So first you hit the 3, then you hit the store, then you hit the alpha. R, I said, was on the multiplication, so that's there. Okay? And next we got to store 16 for N. 16 store alpha N. There we go. So now the calculator understands those 3 values. So now I'm going to type the formula in, right? So the formula is alpha A times, and I'm going to use the fraction format, alpha y equals 1. And now I don't need to worry about parentheses here. All right, so I'll say 1 minus alpha R raised to the N, alpha N. Got a right arrow to get out of the exponent, right arrow get to the bottom, and then 1 minus alpha R. So now when I hit R, or hit enter, it should do the whole same calculation for me. So if you ever have to work with a formula, in order of operations, we make mistakes with that. We honestly do. Okay, but this is the way then you'll never make a mistake with it again. Store values in the calculator. Okay. So let's see. So now we're going to try to evaluate a geometric series. The first question is it geometric? And not is it? It is. It says it's geometric, but why is it? When you look at that you would know this is a geometric series. Remember, if it's arithmetic, then the formula should look like it's linear, like mx plus b. If it's geometric, then the formula should look like it's exponential. And this looks like it's exponential. So that's why if you get this, because on the test they'll tell you that a lot of the questions don't tell you which one to use. I mean, you've got to look at it and say, oh, is this geometric or is this arithmetic? And use the right formula. You've got the formula, right? That's given. Right. So this is geometric because it looks like it's exponential. Okay. What is the r? The r is whatever is being raised to a power. So it's 3. Right? That's why every time you increase the I by 1, you get another factor of 3. You just multiplied by that number again. Okay, well that's what R does. Okay. And how do you find the first term? How do you find the first term? It's the same way that we found the first term with last night's homework. You plug in the lower limit. Right? You plug in 1 here. Right? So the 3 things I'm going to plug in are right here. I'm going to go A1. A1 is what I get when I plug that in. And what will I get if I plug in 1 for I? 4, right? 1 minus 1 is 0. 3 to the 0 is 1. So the whole thing is 4. Okay, the R is 3, right? In this format, that's the easy one. You could tell that right away. And the N, how many terms are there? 16. So this is actually the same calculation we just did. That's what it looks like if it's in a summation notation. So we would plug in S16 equals 4 times 1 minus 3 to the 16th over 1 minus 3. And of course, we get the same thing. Just remember, if the formula looks exponential, that's geometric. And the R is whatever is being raised to the power. Okay, in 1990, total box office revenue at U.S. movie theaters was about $5.02 billion. From 1990 through 2003, the total box office revenue increased by about 5.9% per year. Write the formula for AN and let N equal 1 represent 1990. And then what was the total box office revenue in the period 1990 to 2003? So what are they asking us on the second question? Right, and the first one they're telling us find the formula for AN. What are they asking you in the second one? Total box office revenue? Yeah, it's the sum. You got to add them up. Right, that's what they're asking for. So let's see. So the AN, let's see. We need to know the first term and the R. Okay. So the first term is what? $5.02 billion, right? They said in 1990 it was $5.02 billion. So these are in billions of dollars. Okay. Now, what is the R going to be? It says that it's increasing by 5.9% per year. Now, this kind of relates to when we did exponential functions, that exponential functions had a formula like this. Y equals A times B to the X. And when we did the word problems, the B could either be a growth factor or it could be a decay factor, right? If it was a growth factor, it was actually 1 plus the growth rate. So what is our R going to be here? Remember, this is the thing that you're going to multiply so that you get 5.9% more the next year. What's that? No. You're on the right track. It's not 1 plus 5.9. What is it 1 plus? How do you do a decimal percent? You don't do 5.9 in the calculator. What do you put in? 0.059. Okay, so this R is going to be 1 plus 0.059. So that's 1.059. It's a number that's a little bit bigger than 1, so when we multiply, you should get a little bit more than you had the year before. Okay, and let's see. So that's going to make our formula for AN. AN equals the first term, 5.02, times 1.059 to the n minus 1. Okay. So now we need to find the sum. They say find the total. You know, if that's the formula for the nth term, then we ought to have enough information to find the sum for this period right here. So if 1990 was year 1, then what year is 2003? 14, right? So in fact, that means our n is going to be 14 for when we find the sum. So here's what we'll plug in. S14 equals the first term, 5.02, times 1 minus 1.059 raised to the 14th divided by 1 minus 1.059. Okay, now, calculator time. I mean, no way we're doing that calculation without a calculator. But again, what I'm going to do is I'm going to let the calculator do this stuff for me. I'm going to just store A, R, and N. So let me restore. My A is 5.02. 5.02 stow alpha A. All right, my R is 1.059. 1.059 store alpha. Where's multiplication? There, R. My N is 14. 14 store alpha N. Okay, now I just need to put in the formula. But actually, I already put in the formula, so I don't need to do it again. Right? If you want to pull up things that you just typed, you do second enter. So like the first time I do second enter, it brings up the last thing, storing for N. Okay, then it brings up storing for R. Then it brings up storing for A. And then it brings up my formula. So when I hit enter, it's going to evaluate that formula for the new values of A, R, and N. So enter. And it looks like it's what, 104.76 billion? Does that look right? So that's another strength. If you're using the calculator to store the values, if you put it in a formula, you could do quadratic formula with this. Right? All you have to do if you get a new problem is just restore A, B, and C, then bring up what you already typed in there, and you'll have it. Yeah, but just have to get used to typing all this stuff in the calculator. Make it look exactly in the calculator like it does in the formula. Okay. How far do we have to go? Okay. So now we get to the fact that with geometric series, there's times when you can evaluate an infinite geometric series. So, and this is going to explain why or when. I mean, we did the explanation the other day to say, you know, if I'm going from this side of the screen to the other, going halfway to the end with each step, that's geometric, right? It looks like the R is 1/2. But I'm never going to get quite to the end. I'm going to get infinitely close. So we would say that the sum is converging to whatever that is. Now, if the condition for which that is true is that the absolute value of R has to be less than 1. Or another way of saying that, the terms have to be getting smaller. As long as the terms are getting smaller, then it's going to converge to a sum. So let's take, for example, me walking to the other side. R is 1/2. if I have the sum of one term, right, it'll be 1/2 to the 1 is 1/2. 1/2 squared is 1/4. 1/2 to the third is 1/8, right? As the n gets bigger, what's happening to the fraction? It's getting smaller, okay? Well, what's going to happen as we let n go towards infinity, kind of like n behavior stuff, right? If I raise 1/2 to the 100th power, I mean, it's going to be so small that it's practically zero. So definitely if you let n go towards infinity, what happens in this formula is that the r to the n, because the r is less than 1, that whole term just approaches zero. So if you take away this minus r to the n in that formula, you have that formula. That's the formula for the sum of an infinite geometric series. Right? It's just this thing here, but the r to the n is gone. It's zero. Now, in the formula sheet, it says S infinity. All right, they have a subscription. That makes it pretty obvious what that's for. Most of the time, I don't see them using the infinity symbol. Usually, if you have capital S and there's no subscript, that means it's infinity. If it has the n, that means it's finite. So that's how you know which one to use. But on the formula sheet, they definitely say S sub infinity for the infinite sum. And that's, in the end, that's a pretty easy formula, right? It's only two things, A1 and R. Right? There's no more n because you let the n go towards infinity. And it's absolute value because it could also be like negative 1/2, right? It could be positive 1/2 or negative 1/2. But it can't be 2 and it can't be negative 2, right? Because negative 2, the absolute value is 2. That's too big. So let's see how this works. Okay, so here's an infinite sum. I know it because it's got infinity on top of that. So again, I would like to use this formula, right, but I can only use that if r, absolute value of r, is less than 1. Is it? What is the value of r in this problem? Right, remember, whatever is being raised to the power, that is r. So r is definitely less than 1, so we can use the formula. So we need two pieces of information. R, which we already said, that's 0.8. And we also need to know the first term. So again, how do I find the first term? Plug in this 1 right there. And that's going to give me 5 times 0.8 to the 0, which is what? 5. Right? 0.8 to the 0 is 1. So that's all I have to plug in. I'll use the infinity symbol. S infinity equals 5 divided by 1 minus 0.8. 5 divided by 0.2, which is 25. Yeah, you could put that in the calculator, right? But what would you use for the infinity symbol? Yeah, a big number, but not too big. Right? Usually 50 works. So you could try it. And where do you find the summation in the calculator? Math 0 or alpha window. I mean, there's a couple places to find it, but you could put this in the calculator easily enough. You don't have an infinity symbol, so you put 50 or 100 or whatever you take. Okay. Okay, how about this one? This one's not written as a summation. Before we even try, will this sum converge? Meaning, is the absolute value of r less than 1? I mean, all you need to look at is, are the terms getting smaller? Yeah, it goes from 1 to 3/4 to 9/16. Yeah, the terms are getting smaller, so yes, we can find the sum. But again, we need two pieces of information. We need the first term, which we've got, and then we need the r, right? And the r is the ratio of consecutive terms. But in this case, negative 3/4 divided by 1 is just negative 3/4. So that's what goes into your formula. S infinity equals 1 over 1 minus negative 3/4, right? Which is 1 over 1 plus 3/4, which is 1 over 7/4, which is 4/7. If some of that is things you're likely to make a mistake with, again, use the calculator. I mean, you could have, like, even at this, you could store, and we could easily just store R and A. That's all you would need to put in there. Or just put it in the fraction format here. Alpha y equals 1, and I'll just put 1 over 1 minus negative, and I can use the fraction format again, 3/4. Enter. 4/7. So it'll get all that right. So you try. Find the sum. Right? The R, that's the R. The first term is what you get if you plug in the 1 there. So A1 is 1. So the infinite sum is 1 over 1 minus negative 1/2. So that's 1 over 1 plus 1/2, which is 1 over 3/2, which is 2/3. Right? I mean, honestly, that should be a simple calculation, not even calculator time. But if you don't find that to be simple, then use the calculator, because we can't be making mistakes like 1 divided by a fraction that you don't know that you flipped the fraction. That goes back way long time ago that was supposedly learned and mastered. But if you didn't, use the calculator. That's not the place you want to be making silly mistakes. And I'm going to count massively off if we're doing that. Just silly. Right. Okay, find the sum. Anna gets it. Okay, stop. What's the value of R? It's bigger than 1. You can't use the formula. There's just no sum. Right? You got to look. It's the first thing you got to tell, right? If it's in the summation notation, if the R is greater than 1, you stop. If it's not, if it's like the terms written out, if the terms are getting bigger, you stop, because it won't have a sum. Right? So you've got to catch yourself on that. So R is greater than 1. So you would just say no sum. No sum. The term's got to be getting smaller. And I think I got one more slide. Okay, one more, and that's the end. So in this case, the A1 is easy to find. And then the R should be 3/4 divided by 3, right? Which is like 3/4 times 1/3, which is 1/4. So the infinite sum should be the first term divided by 1 minus R, which is 3 divided by 3/4, which is 3 times 4/3, which is 4. That's it. And that's homework.